Okay, and then I'm gonna put this. What would it be called? NCS Palm background music. Let's see if I can get.
Should you even have background music if it's gonna constantly be breaking copyright laws?
No copyright. Like royalty-free music. Yeah, no copyright songs is like it's like a label, I think, that they buy a bunch of songs and they make it free for everybody.
Yeah.
I think it's like an actual tag, NCS. Actually, let me Google it. What is NCS? NCS can refer to no. Okay, so that's definitely not what it's made. Okay, or it can refer to no copyright music, a British recording label that releases royalty-free electronic dance music. There you go.
Yeah, okay.
Alright, so refresh my page. Let's see what's going on. Okay, yeah. So we're live. Okay. Aha!
Okay, so let me get to it.
Also, yeah, the reason, by the way, why we use time to clear this up is so that it makes sense when people are looking at it. You know?
Yeah.
Okay, so for example, if I open location, and then I create a shortcut. What? Dude. Oh, I'm moving all kinds of stuff. Okay, here's Oracle Box. Here you go, honey. Aha! Okay, full screen.
That's funny, Oracle Box.
Well, okay, Oracle Virtual Box, but you know, it's
I like
close.
Oracle Box. That's a good one.
Okay, so you see Oracle Box here. Pretty simple. How do we begin this? I guess we say what's happening is, okay, I went to school in a university. I'm in university now. That's what I'm trying to say. And also, it's about engineering, data science, all kinds of data and network structures, and all kinds of anything to do with computers, basically. You know. Yeah. And so we're gonna be working on, the test from this one course.
All right.
Yeah, that's as good as I'm gonna go with that. Okay, so the first thing we would need to do is download something called vCore. But since I already thing right, it is a file. It's an OVA file that basically is an it's an entire OS into the VirtualBox, right?
Right, yeah.
And that was downloaded from the course. I'm not gonna put the link to this thing on the internet since it is a Turku EMK like official link, so I'm not gonna, just in case.
Probably it's not supposed to be available to everybody in the world.
Yeah, but it's very simple. Basically, when you have VirtualBox open, okay.
People will probably be able to make their own anyway.
Yeah.
If they're interested in following along. Once you tell them what the vCore contains.
Well,
what the operating system is and everything.
Because they don't really explain. Weirdly enough, the teachers are trying to keep it really simple for everybody, so they don't explain what this is. It is just called vCore in the.
But you can do certain things to find out what operating system is being used.
Oh, it's Ubuntu. Guaranteed.
Okay, well, there you go.
Ubuntu. Yeah. But okay, so basically,
that's what I'm talking about. So, somebody who kind of knows what they're doing could replicate your system, figuring out which Ubuntu it is and what software you're going to be using in Ubuntu.
I wonder if this is made by Turku EMK and not It's not like open source info.
No, I'm quite sure that it's open source, that anybody can do it. Most universities have gone that way, and they don't work with closed source stuff. It costs too much money. It doesn't make sense, in so many different ways. When it comes to educational systems and ideas, it's just
It doesn't make much sense for it to, but
yeah.
maybe it's like purchased through another campus or something. Maybe.
Yeah, I doubt if there was any purchasing going on.
But check this out. First task was of course to download it and import it. I already have it here. And then the next thing he put in here is Ubuntu is going to try to update to version 24. Do not do this; it blows up the entire core down like installation. Okay.
Yeah, exactly. Yeah,
I was like, okay, that's
this is really important to know.
yeah. So I was like, okay. Well, then we basically at this point I already did the first two, but I want to still go through them. Let me go get
Anyway,
that.
Yeah,
Yeah?
there's this.
You keep
concept
getting
of-
quieter and quieter. There's no way, dude. I keep putting you louder and louder. You are gonna have to fix your mic.
No, I'm not getting any louder than this. So
Okay, I have to then put you so loud that it's gonna be
okay,
insane.
just make me louder.
Boom, you're at 8 decibels extra.
Yeah. Okay.
Cause I want to see you in the yellow zone on the streaming.
Yeah. So
Funny.
when it comes to these operating systems and what do you call it, the software that is going to be running on it, you have the concept of dependencies.
Yeah.
These without the dependencies, these things will not operate properly. Either the operating system or the software.
Yeah.
So that is probably why they don't want you updating, even though you probably should, thinking of security issues.
But I'm wondering if this file is an OS in its entirety and they only know how to work with it in its current state and not an updated state. That also might be why they do that, because the teachers would have to then manage 100 people updating a thing, which
Yeah.
is a lot of work. Just getting one person to update something is already more work than it needs to be.
Yeah, we were talking about this concept earlier, the immutable operating system. This is something really necessary when you are teaching like a lot of students, or you have a lot of people in an office, so that they all have the exact same operating system.
Yeah.
That nobody's done anything different from anybody else, so you can more easily support them if they're having difficulties.
Because
'Cause
IT work would be impossible if you had to, in a
Well,
office of like
yeah.
50 people, go to each computer.
Yeah, it does make it more difficult.
Okay, but did you want to see the first task?
Yeah.
So, wait. Actually, is the first... What is this? I guess the first task was actually just to download. Yeah, okay, so yeah, the first assignment was literally just to make this thing. Yeah, here it
So-
even is.
Did they have all of the settings? Like the general settings, the system settings, the display settings. Was all of that
That's all automatic.
automatic?
Yeah,
Okay.
that was in the file. You just imported the thing from here. Appliances and put the entire thing in, and it worked from the get-go,
Okay, so when it says network, is it using your network card, or is this just a virtual one?
Within a vCore, they have a virtual simulator of networks, and so we won't be actually showing my internal and or external IP in these tasks.
Okay.
So yeah, I wanted to go through all them, but there was a couple that require you to basically ping yourself in real life, and that's just, I can't really do that without doing, at least on stream I can't do that. But introduction, they are basically telling how the core is a open source tool for building
Oh,
virtual
there you go.
networks, as well as for connecting the live running emulator to physical networks and routers. As an emulator, Core builds a representation of a real computer network and runs it in real time, where simulations only use abstractions of network models. Core allows for running real services, appliances, and protocols provided by Linux operating system. You know, because it's Ubuntu based.
Yeah.
The assignment, download it, you know, onto your computer. From It's Learning, that's where we download all our stuff. Yeah.
Yeah.
Then you know, import the downloaded OVA file. You know.
Yeah.
Start vCore machine. Launch the application. You know,
Okay, so
emulator.
you still haven't done that yet, so you have to do that.
So over here, you can either go start or you can double click it. Open up the core. It's warming up here. Then get to know your menus, user interface, and find tools in which you can enter your name as an annotation to the square ruler background. So you'll see what that means soon. Take a screenshot from the graphical user interface, GUI.
Yeah, proving that you've done it.
Yeah, basically, yeah. So here it's spinning up. Let me close this thing on the right so that we don't need to see VirtualBox's own opinions. I'm actually also gonna close VirtualBox, the VirtualBox launcher, because this is also not needed for anything after this. Here we go.
Okay, so you have some icons in the... Oh, I need to answer the phone for a minute.
Okay, well, that's happening.
Hold on, I need to mute.
Yeah?
Hold on. I have to go through several menus in order to...
Yeah. It's fine. So I'm gonna do for the stream. Launch the core application from the application menu. The core application that they're talking about is this thing over here, the core network emulator. You click on this. It'll open up the core session. This is a cool app already. There's a lot you can do here. But the first task, literally from the whole thing, was simply to get to know the GUI, basically, to know what all these things do, or not know, but at least see what they do. There's different ways of viewing, tools, auto grid. This is one of the important parts for the next task, is the widgets. There's observation widgets, adjacencies, and then throughput. This needs to be enabled for a lot of the future tasks that come up. There's sessions, help, you know, if you want to know more about core, there's that. The basic part of the program here is you can start a session. Right now there's nothing in the grid, so starting it right here is telling you how much it's running. Nothing's happening because there's nothing there to emulate. You have your selection tool to select multiple computers, or you know, to click on things, and you know. Then you have the link. The problem is I can't really link anything because I don't have anything to link from and or to. Then this is where it starts getting more complex, is you have these options for, you know, adding to a scene. Like you can add PCs.
Yeah.
MDRs, routers, P routers, Dockers, LXCs.
I don't know what they mean by MDR.
Well, we can check the config.
Because that looks like a route. That looks like a router, but I would have to look that up.
Google up MDR and see, because we don't use this in at least for a couple of first tasks, so.
Okay, hold on.
But the first task was basically clicking here at the bottom, going to text here, and adding your name. Yeah, and you can also put cool fonts and sizes if you want, you know, bold it. Then you have your name. This is for the task if anybody needs
Okay,
it.
well, I don't know if this is correct, but
What are they
this
saying?
is a security device. It's called a managed detection and response, a cybersecurity service. If that's what it is, that's interesting.
I'm looking at MDR also, but I don't think I'm finding the correct MDR.
I paired it with the word networking.
Okay.
Managed detection and response is what I get when pairing it with networking. So,
Well, I guess. You know what? I'm gonna do the AI because it is better at finding general information. What do MDR routers do, and or what do they do differently to normal routers? Aren't like standard category of normal routers, so let's keep up the terminology or clear up the terminology. It sounds like there might be some confusion between MDR and router concepts. What a normal router does connects different networks, usually home to office networks, to the internet. Forward packets between devices based on IP addresses, often includes extra features like NAT, DHCP, firewall, and Wi-Fi. Okay, those are all protocols. What MDR usually means. MDR typically means managed detection and response. This is a cybersecurity service, not a type of router. MDR is provided by a security company as a service, not by a physical router device. It
this
uses
is
threat detection, monitoring, and response to protect your network or endpoints. MDR systems often monitor routers, firewalls, and endpoints and cloud systems to detect attacks, but do not replace routers. Okay, so this is more like Cloudflare with MDR.
Well,
That's how I would see it. That's like,
yeah,
we're detecting a DDoS attack. Let's stop that.
yeah, it threw me off because the background symbol is like a router symbol.
Oh yeah, yeah, because here was a normal router, and then here's a MDR. And I like that the only difference is the other one has the word the MDR right there.
Okay, well, good. That clears it up. And then they have Docker containers and Linux containers, and what else was there? Podman containers.
Podman? I've never heard of Podman. Or, well, LXCs I have because of the virtualization.
Yeah, the bottom three, they're all different ways of containerizing everything from programs to operating systems.
Okay, so that's why I've heard of these two. Because, what was it called? Proxmox uses these quite a lot for data storage.
Because in theory, if you want to seriously optimize something so that it is using as little memory and hard disk and all of that as possible, then you would have the program and all of its dependencies that is necessary to run just that program.
In an LX. Oh,
in the
LXC,
container, yeah.
Because I have to say, this is how I'm running my music server, for example. Is all the data is in an LXC, and then the song server, the part that processes the pull requests, that's all on its own thing, but all the info is on an LXC.
Yeah.
You can't get quieter, dude. That's not allowed.
Yeah.
Because I mean, I'm blasting you, and you kept getting quieter and quieter. I'm like, this guy. There's no volume boosting that's possible if you can't.
I have a very bad voice right now because I'm so sick.
Yeah, but it's fine. If you, by the way, I was wondering, I was gonna ask you before the stream if you wanted to stream because you were so sick.
Yeah, but I'm so interested in this. I would hate to not be, looking at it.
Okay. But then after we go through the PCs and routers, we go to the switches, hubs, switches, WLAN, wireless, E-main, RG45, and a tunnel. Thing is, I
Okay,
don't know
now
anything past wireless.
I don't know what E-main is because I haven't seen that one.
It has the same icon as WLAN and wireless, so it might be like Bluetooth.
Really?
I don't know, dude. I'm guessing at this point.
But I have to look it up because I have never seen that before.
Oh, you know what I can do is I can take a hello Shia. I can take a thing like this to a copy and go to my friendly AI and be like,
So
what
it
do
means
these-
extendable mobile ad hoc network emulator.
We're not
So
far enough into logic to know what an ad hoc is.
Ad hoc is like you can go into and out of this network very easily. It's a next generation framework for real-time modeling of mobile network systems. So you know how you have antennas, and while you're going from point A to point B, you go from one antenna to the next antenna. Each time you enter a different antenna's area, depending on the strength of the signal, it will change you from one antenna to the next. So yeah, you're kind of entering the network, each antenna's area and network on an ad hoc basis. So it depends on so many things, but that's generally the idea. Yeah, this is exactly it.
You understand the line being obviously a direction of movement.
Like you're traveling from point A to point B.
These are the E-main, cellular towers. Yeah.
Yeah.
And then when you go here into this, it would automatically connect, and then here it would swap, and here it would swap again, right? That's what you're talking about.
Yeah.
It wasn't 2G and 3G cellular towers based on E-main.
I think that this is a much even more newer concept, because I think that they are making it so that your cellular phones can now also join in an ad hoc fashion wireless networks in your home.
Oh.
So you would be using your own router.
As a cellular tower. That's an interesting idea. Okay, that's kind of cool. Yeah? Why not? The networks are so fast that they're actually as fast as the cellular ones now. Or faster at this point. Oh, Lucia, what are you trying to do? I'm gonna just go through all my courses tasks. Well, maybe not all of them at this, this, what we're doing now, because we probably won't be able to do them all, just because of the time. But we are basically trying to do all the tasks. Also, I'm gonna be, when we go through this, I'm also going to be maybe editing them into videos for other students to see as a guide for the class, so that I would make a step by step, like, oh, this is how you do this task. This is how you do this task. These are the problems found in this task, so look for those. Stuff like that, make it so that people have an easier time doing their schoolwork.
Yeah.
Okay, but tunnels I haven't heard about. They are.
You know what a tunnel is, right?
Yeah, a thing you drive through.
Yeah.
Don't really do anything. What's the difference between a tunnel and a switch then?
Well, you know what a VPN is.
Yeah.
A VPN is the
yeah,
tunnel.
I know. Okay, yeah. So.
Yeah.
So you would probably, if you wanted to directly connect, you'd do something like that. But if you want to skip it, you would go through a tunnel.
Well, the tunnel would probably be in between you and the switch, and then theoretically in between the switch and another point, depending on what you're going to do, because the tunnel is going to be for encrypting your traffic.
Yeah.
So that not everybody can snoop on what you're communicating about.
So basically, a switch will tell the next computer exactly who you are and what you're sending, while a tunnel will take the info, scramble it, and not tell who sent it, and then get the like request from the other computer without telling too much info about you, or telling it false info, and then it sends it back. The
Yeah.
tunnel decrypts it and then sends it back to you.
Yeah, in a way, this is a pretty good drawing because this is two different methods for reaching the same, let's say, distant source.
Yeah.
Either you go through a switch by wired or wireless method
Mhm.
all the way to the destination, or you go through a tunnel. Anybody in between you and the destination can see everything
Yeah.
that
'Cause,
you are
like,
doing.
theoretically, if you had a computer here connected to the switch and you had it sniffing, you could theoretically get this computer's information,
Yeah,
but you can't. Like, if I have a computer over here connected to here, weirdly enough, it's actually got unexpected keyword options. Okay. Well, anyway, this computer for some reason has the same IP as this computer, and so this would actually not work.
well,
192.168.120, same thing.
what?
120.
Yeah. What you would be doing right here is, if you had this, is you would be creating a man in the middle. Is it called vulnerability hack?
Yeah.
So what you would be trying to do is everything that is sent to this original computer is also sent to you.
Oh, so this sends it to the tunnel and then sends it over here, and these guys know to send it back into the tunnel, and the tunnel knows to send it to these IPs, but
Yeah.
these IPs are identical. You see?
Yeah.
And so it would copy this info and send it to like multiple locations.
Yeah, that is what could possibly be happening. Yes.
But let's get back to
As
the
you
task.
can see, it gets very complicated very fast.
Okay, so let me open up the task. Well, we already did this one. This one has been done now. The first, setting up vCore, which is we put our name in there as by clicking here, text. There you go. Not too hard, not too difficult. Want to delete it though. Okay. Let me open up the second task. This one is called vCore 2 Ethernet switch. Okay, so it's all in English. Wonderful. Okay, I'm gonna still just simply open this, and open this and move it. Is there a way to okay, maybe I can just pull it over here. There we go. Alright. Do you see the task?
Yeah, create a local network with vCore emulator.
That's this. So the specifications for the LAN that they want us to make is this network, the one we're creating, has 3 PCs and 1 Ethernet switch. And so we start by, of course, adding 3 PCs, simply, and then 1 Ethernet switch. So the Ethernet switch is this one.
Yeah.
Looks like that. There's no other switches in the entire game, so you have to assume that that's what's up.
I like it that you call it a game.
Life the game.
Because this is kind of a game in a way.
Okay, I'm gonna
a game more closer to real life,
Yeah. Okay, so here we have specify that link speeds are visible. And so they don't actually, weirdly enough, specify that you should connect these, But by
Well,
having the linking tool, you should actually
well, of
do
course
this.
you have to connect them. But now, how
Yeah.
do you specify that on each one of those links that it's going to that it's going to show the link speed? How
So
do you do that?
this is actually this is where I'm gonna instantly go into teaching people how to not do it wrong. Because I did it wrong multiple times, and I was like, what am I doing wrong? Because I thought, okay, they say something about link speeds, so I thought, okay,
Yeah.
if you right click one of the links and configure, there's the bandwidth.
Yeah.
So, oh, specified link speeds are visible. So if you put 10 here, okay, it says 10 bits per second. And you're like,
Which is
that's,
really little.
yeah, specified link speeds are visible. This is how I understood it. It was wrong.
Yeah.
This actually, you should not be putting anything here.
Yeah.
Up here in the widgets, in the throughput, you have to enable throughput. And this, I'll show what this means, but we'll not put it on it. And I'll show you what this means. Add your name to the template. We have name scale here. Generate traffic between two nodes using this command, you know, and replace the IP with one in the scenario. But the problem is the one in the scenario is the default one, so we can just copy the thing, you know. Also, let me just skip this on. Sounds too weird. Okay, so when you wanna like generate like show that it's on, we have to actually start the session by clicking this button up here.
Yeah,
This
but
point,
you
Oh.
still haven't you haven't specified that link speeds are visible.
that is true, but check this out. By taking, let me full screen this so that it's, let me do this here, like that. So here's a terminal. I opened up the first N1 computer terminal. You can see here, it is the N1 config, right?
Yeah.
So here you can do the ping command.
Yeah.
Now, by doing this ping command, I'm actually theoretically pinging myself, if I understand correctly.
Yeah.
Because the N1, you're also very quiet again. So if, yo,
Well, there's nothing I can do about that.
I mean, Are you
I'm
like-
I'm very quiet.
okay. Anyway, the IP for N1 is 192.168.0.20.
Yeah.
And the ping command is pinging in I guess I don't really know what the S means, honestly. I know this is the packet size. I don't know what the S.
Okay. Yeah, I don't remember, but I think it may refer to seconds.
Oh yeah, ping every second 50. Yeah, and that's about approximately how fast it was going. Let's go see. 1, 2, 3, 4. Yeah, that's about as fast. Oh, that's the wrong command. Okay. So we were actually pinging ourselves, so nothing was happening with the network. So what we want to do is we want to change the IP that it pings to, let's say 21, and that's the next computer over, N1.
It's kind of interesting that the switch doesn't have an IP address.
Well, you're thinking more about routers at that point, because the switch is
well-
basically just a way to connect these three computers directly to each other.
Okay.
Okay.
Yeah,
He's so quiet.
I'm just gonna go with that, because
Is it not? Is it not true?
yeah, it's true, but there are of course exceptions. That's why I'm just trying to follow along.
Okay, but notice how nothing is showing link speeds.
Yeah,
Like,
because you
could-
haven't enabled it yet somehow.
If I go to throughput, widgets throughput, and enable it, and I make data transfer happen, you can see now that these have become thick, and it's
Now we
showing
have
you.
a link speed. Yeah.
Yeah, and notice how it is giving kilobits back and forth. You know.
So which setting turned that on?
So that was the widgets throughput enable throughput. This is actually not said anywhere in the task. So if I move this over here,
Yeah.
here when it says specify link speeds are visible, I think this was worded badly.
Well,
Because
try using the help to find something about link speed.
okay, well, let's max this out. Core
Core,
documentation.
yeah, documentation.
I wonder if that's open it in universe. It might not. It might not. Okay, it actually does. Okay.
Yeah.
It does have internet too.
And now, if they have a search box, type in link speed.
Linking nodes to Vallon. Configuring links. Okay. Python configuring links. Tutorial wired. It doesn't have the word speed in there, but it has the link, the word, link these two things together. Same thing here, no words of speed. This is kind of what I was looking for. Like if I remove link entirely and just go with speed.
Or maybe just link.
Well, that's gonna find a lot of things. That was kind of what I was finding earlier. 18 matches. Link 3, MDR nodes. It's talking about the linking tool at this point. And that's quite largely used, so it's talking about it everywhere.
Okay, so let's go to ChatGPT and ask about this core.
All right, so
ask how would you say this? Okay, yeah, emulator, and how do you enable link speed be visible? I guess I don't know. My thinking process is really bad right now.
let's see if they get it right. 'Cause, I mean, I already got the task correctly by doing the throughput thing. So
Yeah.
we know what they are asking for. We just don't know. Because AI is probably gonna get this wrong because it got it wrong last time. But what it means to specify link speeds in core, this emulator, network emulator, you can create virtual networks and topographies. To specify link themes, setting the bandwidth, data rate, and latency delay to the link that connected the. But they say this. This is inaccurate because when I changed the bandwidth or the latency, I didn't get a pass rate on the thing, so I had to change it. You know.
Oh yeah.
Because they're talking about talking about link configuration.
Let me just say that what it says initially is not incorrect. That is one thing that you can do. Because you're setting the bandwidth, data rate, or the latency, the delay of the links that connect to the different nodes in your emulated environment, and this lets you simulate what happens on slow versus fast links, like a really old dial-up line or a fiber optic line.
Yeah.
Okay, but then these other things that you have here in that next answer, those were in that thing that you opened up when you, I think, right-clicked the line.
Yeah, so when you go into here, I wonder if you can do it. Okay, you can't. Oh, you can. So when you right-click a link, you can go either that it's symmetrical links FX, so going up and down is the similar.
Yeah.
But if you want to specify, you can make download and upstream. So
asymmetric is the most common form of networking connection.
But since most of the classroom is pretty simple, we're probably not going to be talking about asymmetric effect, you know?
Because I can guarantee you everybody would like to have a symmetrical network connection. That means that I can download, 100 megabytes and upload 100 megabytes per second.
I wonder why upload has been kind of left behind. I think we're doing way more downloading in the networks than uploading.
It's a way to centralize control over what you can do on the internet, so that you have to go through certain entities and pay them money.
I guess. Yeah.
Because if everybody could really run their own game server at full speed and download and upload everything at full speed, then these companies would not be able to exist.
At least not for long. Yeah.
Yeah, or not on the scale that they can exist. When you're talking about multiple billions and billions of dollars, hundreds of billions, they would not be able to exist at that level if everybody could do this at a symmetric level of networking.
Check this out. So, then you take a screenshot and deliver it, basically.
Yeah.
You know, because this is what it was asking for.
Okay. Have you just started a ping in between two of them, but not the third one?
Yeah, because I'm pretty sure that because they wanted 3 PCs, and when you show the throughput, it makes these too thick, right? And
Yeah.
So I think for them to have an easier time checking the work, they wanted there to be shown that one of the things is not being pinged.
Oh,
But you
okay.
I can theoretically, if I, what is it called? Can I write stuff? Okay, when it's pinging, I can't write stuff. for some
You have
reason.
to type Control-C to break out of it.
Yeah, but that will then. You're correct. Yes, Control C does stop it, but
yeah.
it stops these, so you can only ping like one direction at once.
Can you only ping one at a time, or can you ping two of them?
No, well, not from one device. It doesn't seem to want to allow you to ping it from.
Okay, so you have to have multiple terminals or 2 terminal windows.
Maybe? Can I open it up? Oh, I can.
Yeah, there you go.
Or wait, actually, what was this one from?
That was 22.
So yeah, 20 is currently pinging 22. So if I go 21 and I ping, let's say 20, this should turn into a lot more. There you go. And if we get even this one to ping 20, it should become even bigger.
Yeah.
Now we're hacking, baby.
Yeah, there. You know, notice the link speeds have gone really different.
Yeah. So you can see that, yeah, it's slowing down.
Yeah. Is that a decimal point in between the numbers, or?
Yeah. There's a decimal. Yeah, there's a decimal. There's three decimals later, like after that real.
Oh, that is such a weird way to express things.
Well, if you have like 1.2 kilobytes, it's actually pretty reasonable because that's still, you know.
I've never seen this before, because it's usually an exact number, not a decimal, and then to the thousandth place or whatever.
Yeah.
That's just weird.
Okay, so check this out. So that was that. This is where we get to things which I haven't done. So I have no, like, automatic way of doing this one. Okay, so this one. Okay, this one you're gonna actually have to help me with, because I actually don't know what this means.
And what is it?
I'm gonna open it up. Open it up.
Oh yeah, you probably should Control-C all those terminals, because we don't want to ultimately, break the system.
Yeah. Also, we can just stop the simulation, and then we can. Well, we can either keep. Well, yeah, let's just keep these ones because nothing has really happened. There's just 3 computers to a switch,
Yeah.
Now, let me try to. Oh, try and do like. Okay, there we go. Noni, finally. So, tehtävänanto is the word for the task, that it has been given. Demonstrate routing between 2 LANs using Core. Hint: to avoid manual IP numbering of nodes for each network, first select the IPv4 address range from the menu tool's IP address, then draw links. Okay, so they're saying tools, IP addresses.
I think you have to replace the switch with a router, or connect the switch to a router, and then basically copy that network that you already have and to double it.
Wait. I'm still in the first one. I know you have gone. You've probably read it through and know what's happening.
No, I'm only reading this to avoid manual IP numbering of nodes.
Yeah.
For each network, first select the IPv4 address range from menu tools IP addresses, then draw the links.
Oh, okay. So if I click like this, and I put like a router, did they want a router?
Well, you're gonna have to have two networks, and they have to be connected.
Create a LAN with one switch, the one switch and 3 PCs.
Yeah, you
That
currently
IP
have that already. But the
Do we
IP
want-
range is slightly wrong, or is it the same?
It's the same range, yeah,
Yeah.
because these are all in that network, yeah. So then, okay, well, if I do a switch, and I did the tools IP addresses thing.
So you could basically copy all of this current network that you have here.
Yeah, but would it? Well, let's try it.
That selection tool.
Oh, it didn't save, weirdly enough, the connections.
Well, that is weird. Try the selection tool again.
Yeah, that's weird. Okay, so I can like select them.
Yeah.
Control C,
It's only.
Control V, yeah.
It's, yeah, but there's probably some other thing you're supposed to do, like choose it once again. Okay, right click the entire thing and try that.
You can only right click each device, you can't right click air. You can link.
Try the selection tool again.
Well, oh, copy here. And then Control V. Oh
No,
my
it's
goodness.
doing that.
Okay.
Try the selection tool again. Click on just the selection tool and quit all that other stuff you're doing.
Okay, the selection tool. Boom. Do I select them?
Try right-clicking the selection tool.
Right clicking only allows right click on things.
No, the selection tool.
I have. Oh, this thing? Oh, I'm right
Yeah,
clicking.
try right-clicking that.
Neither do anything specific.
Okay, so they're not going to make this easy for you so that you could just double the...
Dude, it would have been this easy. Boom.
But yeah, I'm just saying that it can't be this easy, but if you've already made a huge network,
Yeah, I see what you mean.
you
but...
really don't want to do what you just have to do there, because it's so much.
Hey, it did. Look, the IP is well organized. So having the...
How did it give you the... like automatically the
So when they
correct
said
IP addresses?
to avoid manually IP number nodes, we go to Tools, IP addresses, and by clicking one of these or adding one, it'll make each of the connections numbered in that.
Ah, okay, I see. Yeah.
Interesting. I didn't know that. And I guess if you click here, enable IPv6s, you can also have that.
Yeah, that's really having fun.
Okay, first select the IPv4 address range. Okay, so we created the first LAN with the 192.168. Yeah, correct?
Now you'll have to add a router and connect the two LANs.
Wait, create another LAN with this. That looks right. Add a router to each LAN to designate a home office router. Okay.
So you have to have two routers then.
Okay, so first I'm gonna move name scale out of here. Okay, I guess it's a normal router.
Yeah.
Okay. Add a third router to designate a network operator router. On internet in general. Okay. A network starts at this. So to make that easy, we should do this. IP address.
Yeah.
Keep this one on. Oh. We link these two. There we go.
Yeah.
It seems to have the same IP in both directions, and these both have
No, you see the top router is just saying that going either to your left or to your right, it's going that this router will always have this IP address.
Me go like this. Because I couldn't see them. So. Oh, there's also a small difference.
It's,
1 10 0 0
oh,
1
okay.
10 0 0 2 and here's 10 0 1 1 1 10 0 1 2.
Okay, yeah, now I can see it. Okay.
Okay, gotta minimize that. They didn't really specify what the link between these should be.
Yeah, but you do need to link them, yeah.
Okay, well they just assumed some kind of something.
Well, it knows, of course, based on these other things that you have chosen, that this is the IP range 172, and that's the IP range 192.
Yeah, I'm trying to line these guys up so it's similar. For no reason. Okay. But then generate traffic using ping, the node from one PC in one LAN to a PC in the other LAN for, enabled throughput. So now they say enable throughput. That's enabled. So let's start this up.
So you'd have to somehow ping from.
Wow, this is unreadable. Okay, one second.
Yeah, you really have to stretch that stuff out because otherwise
having the speed. I'm gonna put it like this. Evil. It's gonna be an evil internet. I don't know why, but this shape somehow makes it evil.
It's looking very much evil, like a guy with three fingers and his head is in between his shoulders.
Oh hell yeah! What is this? Just checking in on the stream and getting flashbacks to the computer science student, of course, yeah. Okay, it's a bit more than my science comp course, yeah. Oh hey, don't worry, we're getting deep. Well, I'm gonna try to teach you guys what the university is gonna teach me through 4 years, okay? I'm gonna slowly get all of you as engineers, and then you guys are gonna know more. Okay. But, we can also stream normal stuff too, sometimes. Yeah?
Yeah.
So, nothing should be moving. There's something moving here. I don't really know why stuff is moving, because nothing...
Well, there is this kind of, what do you call it? How do two things know that they are connected together? This is what they do. They are constantly communicating to one another, telling each other that they exist.
I'm gonna say that so that everybody else hears it. They have to talk. The PCs have to talk to each other to know which network they're in. I'm sorry, you were lagging slightly, so it was unaudible. So I have to say. Yeah. Okay, are you ready?
Yeah, there's this one word I'm looking for, but my brain, like I said, is not working.
Wait, what was it? What was the word connected to?
Well, the word is about in all networks. You have a computer talking to a switch talking back to the computer, and they're telling each other that they exist and they're waiting for information.
Oh, like sniffing?
No, they're just constantly telling one another, "I'm here. Do you have anything?" And the other one saying, "No, I don't have anything right now." It's kind of like this, but it constantly goes on, and that's why you have this small amounts of information going from one device to another.
Just by looking at the system breathe, I don't know if you noticed this, but there's one connection that I can see that has nothing going through it. The link between N11 and N10.
N11?
Routers.
Yeah.
You see how everybody else has something going through it? This guy has something a little bit here, a little bit there. But then this is the only one that does not have anything going. Word that comes to mind is handshaking.
Yeah, it's like handshaking. Yes, click on N11 and do that enable throughput.
Oh, enable throughput is simply a vision thing to see the speeds. It is.
Okay, so it just. Oh, okay. I thought it was actually enabling throughput.
So, but
try repositioning that router to see if we just can't see it.
Okay.
Nope, it's not about seeing it. Now we're making it serious.
Dude, this guy is super evil. His neck is so far down. I can only. Okay, but since it's not location, let us just attempt to ping something from here to the other computer.
Like if you chose that you are in 11, try to ping in 10.
Oh, okay. Let's do that first. Okay. So this is N11's ping. We're pinging it could 10 0 1 2.
Well,
okay, ping is able to, yeah, okay.
But why isn't it showing us the link speed?
Yeah, that's interesting. Well, I don't know. It's it's clearly working.
I wonder if there's a limit into how many of these things then that you can show.
Well, then that is, well, we can't test it yet, but wait, I had one more console open. This should work. Yeah?
Which one are N1?
N1 is talking to N6, or will if I push enter.
I'm not sure about that. Go ahead and try.
So N1 is 192.168.0.20. You know, it goes switch router switch 172.160.20. That's just.
Oh, okay.
Oh, so the throughput is just broken on that, the connection between those two.
Yeah, okay. The reason why it can connect is that you see this local area network, this 192. I was a bit dubious that it could contact 172, but I've forgotten that 172 is like a what is the word? There's a word that describes what type of network it is, that it's more available throughout the internet, that anybody can have access to it.
Oh, a standard?
No, that's I just don't have the words. I'm sorry,
It's fine. Okay, so are you talking about that? Because the moment I saw this task, by the way, I've gotten this wrong and now it's correct, so it's actually pretty cool because we got a task done. But for me, when I saw 172, since I've been working with servers this whole time, I've never seen anybody start any kind of IP ever, anything else than 192.168. So this was actually quite a new thing for me to see that you can put anything else in the first two slots. Just double checking, what's the green one called? My brain ain't working at this time in the morning. Is it a switch or a router? So these ones, let me pause this so that it closes.
The green ones are switches and the blue ones are routers.
Just so that everybody knows what's going on. Also, I can just, I can just do this. If I do this. Well, I guess I'll just put it there. Yeah. And then I can add row with there.
Okay, it's as simple as this. You have private IP addresses, which is the 192, and you have the public IP addresses, which is the 172.
Yeah.
That's the basic difference that everybody can understand. They have much more complicated terminology for all of this. So that's why you can ping that 172 from a private IP address.
So is 172 more open?
So try choosing the 172 address and try to ping the private address.
So by opening N6, or you know what, I'm just gonna open up N8 so that it's the most further, yeah? And I'm going to try to ping the N1 computer.
Yeah.
Yeah?
Okay,
It's
so
able to-
you can't do that. This is something that in many ways is not totally what will happen in reality.
Wait, well let's ask the AIs. Let me now try to find an AI to talk to. What's the difference of 192.168.1.0.0 and 172.16.0.0? So we're gonna get that.
Okay,
Both
well here it says both
192,
are private IP address ranges.
but they belong to different private IP blocks defined by the Internet Assigned Number Authority. Okay. What the hell? I
Well,
didn't know there was an authority
that-
on there.
that-
Or
I
something.
read that wrong. So it is a private IP range.
Tree Chicken also asks, are switches these ones where it will save your LAN address internally, use its own public IP address, and save them together in a table, linking them together so you can connect to your local network area?
Yeah, that's what will happen. Yeah, it's
Yeah?
they have a special word for it, but I forget something type of table. But that's basically the way it works.
Yeah. I'm not gonna lie, I was having a hard time trying to figure out what Tree Chicken said in the chat, but yeah, I think it makes sense. Yeah, because at least that's how, at least in the core, it works like that. Because these guys are able to talk to N11, which is the quote unquote the internet in this scenario. So the switches are connected to router, which
I must say
saves-
that the routers do kind of also work similarly. They have this table of devices that are connected to it. So it has the IP addresses of, like, let's say 10 switches, a computer, a laptop, and a wireless device. All so it has IP addresses for all of those as well. So in a table, so it knows who to contact, who to send the information that it's receiving.
This reminds me, I wanted to show you this. If I had a router and I had PCs, or even PCs into a switch, it gives them all their own IPs.
Yeah, it has to do that. Yeah.
So just so that this is more readable, let's put them on the diagonal. Okay.
I wish there was a way to get the IP addresses and the link speeds to not actually be centered on the line.
Yeah.
The line kind of makes it a little bit difficult to read.
Well, let me see if we can preferences, custom node, show hidden names, preferences maybe, theme black, scaling. Well, scaling makes it okay. That's definitely not a preference I enjoy. What was that? Oh, okay.
Okay, see you later, True Chicken.
Oh, I gotta go. Goodbye. Okay.
Yeah,
but-
that's scaling is really messed up.
Yeah, that was a weird thing. Okay, so routers give each network its own what I don't know what it would call. Because for example, okay, I'm gonna put here. Okay, there, and then I'm gonna add the next one here. 6, 8. Okay, so unlike a switch that keeps them all, you know, like what would you call the third number?
Oh,
Yeah, that's what I mean. Because okay, so a switch, if I go down here, you can see that this switch and all its computers are in the similar third number area. Also, I just realized that my face cam is insanely in the way. So I'm gonna put that over here. You know, while each one of the PCs that are connected, this starts at 0, this is 2, this is 1, and this is 3. So they all have their own. So 0, 1, you know, or wait, 0, 1, 2, and 3, right?
yeah.
And that's not really changeable because it actually gives its own separate ETH direction for each one of those. You can see it here.
Okay, so the last number in the address is the host ID.
Okay,
Or
host
the
ID?
computer. Yeah, they call it the host ID, but it refers to whatever device is connected, computer, phone, whatever.
Yeah.
You know, so when you have like, let's see, how did they all have the same here at the bottom? The
what?
172.16.3.20. All three of these are exactly the same.
Wait, 320, 320, 320. You are correct. They are all 320. I don't think that's correct. I don't. These are duplicates. Yeah, these are all duplicates. You are not reading it wrong. For some reason, they are duplicates for no reason.
Okay, but where's the original network?
Oh, that was over here. But these ones have different host IDs, like they're supposed to. Each one of these have a different host ID.
Now, the first three numbers together, so the 192.168.0,
yeah,
they call that the network ID.
Oh, okay, so network and then the host ID. So which network are you in and which door do I go to, basically?
Yeah.
So I would say 192 is maybe country.
No.
168.
No, 192 is a private network, and 172 is a private network. We've now established that.
Well, let me open up this thing again. I want to actually read this to see what they were gonna say, if that's okay.
So anybody can basically create their own private network in their home or business or whatever, and they can assign their devices these numbers.
Yeah.
And these numbers cannot generally be contacted via the internet. You have to have a special way, like you have an external IP address that the ISP assigns your router.
Yeah.
And you need to be able to give that to people in order for them to contact your computer.
Yeah.
So that's why I'm a little bit thrown by this this thing that we've created. How is it able to ping from one private address through a router to another private IP address? But I don't think that we've gotten there yet. I think they're just starting out very simple.
They are. The next couple of tasks become so difficult that we have to start reading documents. There's actual like white papers on the there's a full document that we're gonna have to read for the next one if I remember correctly.
Okay, but here on this webpage that you have open, this ChatGPT, you can see that if you want to, if you have a very small network and that you will never have more than 65,536 possible addresses in that one. That's the one most people use.
Yeah.
Now, if you are a larger entity and you are over that 65,536, then you have to use this 172 address range. Now, they
Uh,
didn't include it here, but there's one other private address range, which is the one that starts with a 10. That's
yeah, they
you could ask them about that to, so that maybe they will give us the number. But there we go, 16 million possible addresses.
wow. Okay, so
Yeah,
that's yeah, because yeah, the more zeros there are, the more 255s there are. So it's like 255 times 25 times 255.
yeah.
Yeah. Actually, yeah, let me actually pull out a calculator here. And I just this is just for my own see what's oh this and then this 3. Yeah, there you go. Okay, so yeah, that's how you would get that number. Wait, what? What's with the couple of extra ones?
Let's see, 255. Uh, uh, by using the word the number 255, you do, it does include the 0 and the 255.
Oh, no, it doesn't. No, yeah. So it's 256
Yeah,
to the power of 3. There
there
you
you go.
go. Okay, yeah. Okay, yeah. Without yeah, because 0 isn't included
Yeah,
in normal
didn't include
calculations.
the 0. So yeah.
Typically used for very large networks, corporates, IPS, cloud servers, stuff like that.
So like your local ISP probably has something like this, so that they can have the largest possible number of customers.
Yeah. Yeah, so here are huge private networks, medium, and then small home office. I wonder how complex your system has to be at home for it to exceed 65,000.
Yeah, well, all of this was an afterthought, actually. Uh, so there wasn't really ever this idea of creating home networks initially. The whole system was based on the idea that you would have an address between important institutions like universities and scientific institutes and maybe the government. They didn't really have this idea initially when they started out that every home was going to have a huge network. you
Yeah.
know, so they've developed the system over time and expanded it and made. That's why the IP version 4 has lasted so long, as they created these type of possibilities. Uh, and then they have this network address translation system that uh, allows you with your local device to communicate with either other private networks or the internet as a whole.
Hmm.
But they will not give you an IPv4 address which is like owned by somebody like Google or US government or whoever.
By the way, I wanted to ask this. Was this an accurate truth that all MAC addresses are permanent and unique to every device?
It used to be true, but Apple instituted a system where you could basically spoof your MAC address and that it will change it every time you connect to a different device or wireless device or the internet or whatever.
Okay, so they kind of ruined the whole system. Okay.
Yeah, earlier it was a very cool thing because uh, you could actually figure out fairly exactly what equipment people were using to contact you.
Yeah.
It was like a fingerprint.
Well, it's weird that they have removed all the fingerprinting that would make stuff like networking cool and fun, but then they keep all the stuff that makes you a sellable commodity. You know?
Well, a lot of this was supposedly due to privacy issues, so they made it more difficult for especially spammers to know exactly who you are and what computer you have and what equipment you have, and then paint their advertisements to you based on that. Like for example, not too long ago, if you were surfing the internet with an Apple device, an iOS device, before they instituted this, then websites would offer you tickets or products which were more expensive than if you were using a PC, a Microsoft PC
Yeah.
with Windows and everything. And people were studying this, going, "Hey, what's up? This isn't fair." But, people this general idea that anybody who is able to buy Apple devices, which are so expensive, can easily afford to pay more for everything.
Yeah.
Yeah,
But it's the thing is, okay, if you look at their company, it's horrible. You know,
which company?
the Apple and how they get the money from their customers. I don't know. I've seen a lot of stuff where people are reporting that rather than making a phone good and slightly thicker, just because of how their marketing has worked, they keep making them like thinner and thinner, which makes them overheat, which makes them thermal throttle, which makes them slower because they have to slow down the phone so it doesn't heat up because of the compact space that they have stuck all the stuff in. Stuff like that,
Yeah.
they do a lot of that. Every new phone overheats. It's really bad.
Yeah, the battery technology, they're constantly also trying to develop that into a much more complex system that is also much more dangerous so that it can actually explode.
Yeah, because they're like, for example, what was it called? Note 7? The one that was blowing up on planes and people were getting like security checks to check if you had a Note 7 on a plane.
Yeah,
It was like, the battery was blowing up, and it was like, I bet those batteries would not have been there wouldn't have been such volatility in the phone if it wasn't packed so tight.
yeah, probably, but it's the battery technology actually that is the culprit.
Oh yeah.
They would like to create basically instead of a battery system, more of a capacitor system, so that you could plug in your phone, it charges within 10 seconds or less, and it uses that.
Slowly puts it out.
Yeah,
But they haven't figured out a way to make it so that you can charge it. Because capacitors, by default, you can charge them instantly and uncharge them instantly. But
Yeah.
how do you charge them not like uncharge them non-instantly? You know,
yeah, that's the trick, but you can't do it.
here's a circuit board, and here's a capacitor. Boom!
But yeah, now the problem is it also makes it that you have a lot of power, and if something shorts out that system, oh, you're going to have
you no longer have
something
power.
on your hands, which is not good.
So,
But
Let's,
where are we at in this? Let's see.
add a third
Create-
router. That's
Let me
totally-
read each of those points.
Oh, do I zoom
Create
Oh,
create LAN with one switch and 3 PCs in network 192.168.0.024. Create another LAN with one switch and 3 PCs in network 172.16.0.0.4.24. Add router to each LAN with a home office router. Oh, you have actually done that part.
Wait, which one?
You haven't added text to designate like this is your home router and that's your office router.
Uh, add a router to each LAN to designate home or office router.
Yeah,
But
you would
I'm
have to like type in there that this is your home router and this is your office router.
Oh, okay, okay. Let's do that. Man, I wish you could somehow mess with the.
Yeah, somehow your the end designations got offset really far away from the device when you were messing with the resizing or scaling things.
Yeah. I'm trying to
But
make it like nice, but it's
yeah,
almost
but
impossible.
yeah, each of these routers should have like written next to them, this is my home router, and the other one should have this is my office router.
What is this called? This is LAN 1. Yeah?
Should you put home though?
Let me open up. For visual clarity, add annotation borders around all devices belonging to each LAN. Should we consider the router a part of the LAN? In my opinion, it is.
I was working on number 3.
Add a router to each LAN, which we did, to designate home office routers.
Okay.
This is the thing is I don't think that's written very well.
So you don't think you have to write a tag there indicating that this is my office and this is my home?
But then 6 over here is for visual clarity.
Okay.
Annotation borders around all devices belonging to each LAN. So that would basically be the same as the third one's more vague statement of designated.
What I would think that it should be labeled network operator router or
This
internet.
One? Oh, the other one should be internet. Okay.
Yeah.
Well, we'll do this.
Well, that there should be text, like a text, like this. Here you have switch, kind of no longer connected to a switch.
Oh, what is happening? 1 second. 1 second. I'm gonna try my best in making this like this.
All right.
Yeah, the word switch is not connected to anything. You're correct. There you go. I can also add text here. Oh. I'm out. Switch. Okay, what is going on? So there you go. Also, router. No. There you go. Then I can move them to their locations. And then I guess we make another oval down here for internet, right?
Yeah.
Or should we make it really legendary seeming? Oh, I guess we can't do that. Wait, what did you say I should name it?
Oh, I was just going based on the they had in the instructions.
Oh, what was that?
Rather than remaining generic with just router, that one is a home router, one is an office router, one is then this. Okay, I couldn't read it. Like network or router.
Let me do this.
The network operator router. And they seem to be indicating that could also be the internet in general.
Oh, I'm trying to look for what you network operator number. Okay.
It's number 4. Yeah.
What happened?
I think you deleted it.
What the hell? Why would it do that?
Are you pressing Control Z?
I was trying to push Control Z, but then more deleted text than kept it. There we go, and now I simply move it over here.
It's not there. It's this lower one.
This one.
Yeah, that's the network operator router.
Okay, so I'll put this here. Move.
Yeah, like that.
Okay, well, I guess like this.
Yeah.
There's no really good way of doing this.
If you want another text, you could put internet with that area as well.
Yeah, here. Yeah, make that slightly different.
Yeah, some outrageous color. That's what we should choose.
Outrageous color. There we go. This looks pretty good. I'm gonna delete the N11 thing. We don't need that. No name. What if I...
Okay, well, the N11 is useful in the sense that if you right-click it and you open up that terminal, then you can see that it's one of these network devices.
There we go. And no R. There you go.
Yeah.
That's clear.
Yeah, that's better.
So I guess we're gonna not name the routers.
Well, you could do exactly what you did there. Rather than N9 and N10, you could change it to home router, and the other one is office router.
Let me make this like that. This is for
Ease of reading, yeah.
I'm trying to make it so that nothing overlaps. There you
Yes,
go.
if you could move the office router and the home router down just a little bit, you could probably... No, it didn't help. Okay, never mind. I was hoping that it would allow us to see the number better.
It really does not like to allow you to do that.
Actually, we need to take the whole home and office router out of those circles, right? Because they are in a different...
Are they... Wait a second. For visualization, all devices belong to each LAN. Are they part of the LAN or not?
No, they are not part of that LAN. Well, okay, this is the difficult because it partly is and partly isn't.
The internet in general with... Okay. From one PC in a LAN to another PC in a LAN, but they don't... Okay. No, I say that the routers are part of it, in my opinion.
Well, you see that it's half and half. Because it halfway belongs to this network operator router, and it half belongs to the local.
But, okay, for example, all my computers in my house are connected to my router.
Yeah, and your router will have an external IP address assigned to it from the ISP.
That's true, but most people would still consider the device within my house part of the local area network.
But you would not have any connection to the internet without the ISP saying that you exist.
That's true, but then that's like saying I don't have a LAN because I have internet. You know? Which doesn't make sense. So you would have to assume that you have to have a router in your house to have access to the internet in
Yeah.
this scenario. So I say it's a part of it. The thing is, I'm gonna add my name here and then, give the task back.
Wait a minute. We haven't generated traffic,
Ah, yes,
have
that
we?
is true. No, we have to actually have it on and generating traffic. For the picture.
Yeah.
Add your name into the background with text like this. Remember, Scandinavian letters are bad.
Yeah.
So if I put A in there.
Well, okay, it works here in this case, but they don't want you using it normally
Yeah.
because you need to learn this.
Yes, because using that within one of these informations would break it, you know?
Probably, yeah.
So, well, I'm gonna add my name, the legal name, later on, but we'll see. Add your name in the background, take a screenshot, and submit its learning. So, but basically, if you had your name here, you'd
But
begin this.
yeah,
You'd open up one of these. So the task would basically be this. From N1, pinging. Well, I guess it didn't save my earlier thing, so I'm gonna have to rewrite the whole thing. Yeah, that's a computer. Yeah, that's a computer that exists. So I would be pinging N6.
Okay, well, this is definitely broken. Oh, okay. I can see what that they are thinking. Okay, you will make it a much bigger line on a local network, but when it comes to the internet level of network, the line is not going to get that much bigger.
I wonder if I stop this. If I go to show through level on every link, use exponential weighing, okay. Threshold kilobytes per second, 0 disable. I wonder if there's some kind of threshold going on.
Well, a threshold of 250 kilobits per second is really a pretty high number.
Yeah? Should we disable it and see what happens?
Yeah, maybe it will disable all. Yeah, it got rid of all of the link speeds. Or no.
Let me see what happens. Whoa, why are they talking to each other at like a lot? Why are they talking to each other so much?
Well, okay, now that we got rid of the threshold, it's now registering all of the normal communications between each of the devices, like I was talking about. The word I was thinking about is called overhead. There's this constant overhead between networked devices. They constantly talk to one another, telling them that each other exists and they're waiting.
So I guess we put it back. Yeah, and that makes it much quieter.
Yeah, so you won't see most of the traffic below that threshold.
What I don't understand is when the speed is so obviously on, but it doesn't show it. And I think this is a problem with simply the core, thing. So, you know what we could do? Close this, X. Let us file save as, and then call it Tehtava 3. I think it was the third one. Maybe I'm gonna have to check this one.
Okay.
Yeah, this was routing, so this is, yeah. So save that. And I'm just gonna close this. Open it back up.
Yeah.
Because maybe that's
Open. Yeah.
It has crafted.
Oh, you have to enable throughput probably.
Oh, that's not true. So now it broke for some reason.
No, no. Listen, I
Oh,
don't
now it's
think.
going through.
Okay.
And if we do the throughput, there we go. This one is still broken, but most of them
Yeah.
got fixed.
Okay, so it's a little bit of a buggy program, but
You know, it works slightly.
yeah.
Okay, so then what I'm gonna do is I'm gonna stop this. I'm gonna move it to my other screen. Yeah. I'm gonna change the name to mine. And then if I play this. And then it's sending packets. And I'm gonna take a screenshot of this. There we go. Actually, I should probably take this screenshot in a savable form. So that's a screenshot form. And then I delete that my name. Okay, boom.
What type of format did they want?
Well, I'm gonna check the. Well, this one take a screenshot and submit it, and it's learning. So it seems like they are happy with just get a picture.
Happy with what?
Just getting a picture, like a screenshot of the thing.
Yeah, but I was wondering what format, JPEG or PNG or.
Oh, they don't go into such specifications. They basically it takes anything.
All right.
Okay, so I have now sent that forward. Then we go NAT. Okay, so this one. Oh. Okay, so this is where it gets really funny. Okay. So you're like, oh, that was, look how simple this is. Create a lab.
Yeah.
About 8 steps. So here is, a couple more steps. Okay. So what I'm gonna do is I'm gonna new session this.
Yeah.
So we have a clear board. We'll see how far we can get in here because I have to leave at about 2 o'clock.
Should I read this text out loud?
Yes, I'm gonna make it bigger so that there's less bitrate reduction. Okay, this is about as good as I get it.
So IPv4 addresses consist of 4 octets. That's the 4 parts of the address.
Yeah.
Thus creating address space of 2 raised to the 4 times 8. Which is equal to about 4.2 billion addresses possible. On year 2021, there were almost 20 billion devices connected to the internet, with about 5 billion users, more than 2 billion computers, 4 billion mobile devices, 2 billion network sites, 12 billion Internet of Things on devices. So it is very clear that not every device can get its own IPv4 address. However, all these devices can connect to the internet using network address translation. In common setup, all devices in a LAN share one external public IPv4 address. Network address translation at the gateway device takes care that responses to all outbound requests can be mapped back to the original requester. That's what Tree Chicken was asking about, this kind of table system.
Yeah.
Mapping can be based on protocol, message sequence numbers, and TCP UDP port information. This means that it is only possible to initiate communication from within the private network. If there is a new connection packet from a public network to the shared IPv4 address, then there is no mapping for that, and the gateway cannot know which device in the LAN should be the recipient.
So does this then mean that basically Unless you have an identifier and a location where to send information. For example, a public network can't send into a private network because within a private network, there's still a large amount of devices that can and should or should not be recipients. So they can't just send everybody the info, right?
Yeah, yeah. That's why this last sentence was probably the most complicated part of understanding this.
Well, what? If there are no new connection packets from public networks. Oh, wait, if there is a new network packet from a public network to a shared private network address, there are no mappings from that gateway, from that. That the packet doesn't know where to go.
Yeah.
And cannot know which device in the private network should be the recipient. Yeah. So basically, if someone tells me to go attack Garena or a city, and then I go in and I don't know anything about the location, it's gonna be really hard for me to attack it.
Yeah.
With anything, a party and or a military.
Yeah.
Oh, so you have become even quieter. So
I keep trying to not blast everybody's ears with this coughing.
it's fine, dude. You have no clue how quiet the cough is on my side. It is barely.
Okay.
It doesn't even go into the red. Okay, it's like barely normal audio. Okay, you have to
All right.
understand it. Okay, because like after a while, you start getting so quiet, I can't even hear you, and I have my headphones in max blast, dude.
Okay, so useful detail. From the command line, either
Okay.
Windows or Linux, you can use curl ifconfig.me to find out the public IP you are sharing. And note that you are sharing the same one public IP with your neighbors, assuming you are in the same LAN.
But this is the thing that no neighbor is going to be in the same LAN.
Okay, what they're referring to here is like if you were at school.
Oh yeah,
And
neighbor as
you
if
had
you're a friend next to
20 plus computers there. You would
Yeah.
all be using whatever that is.
Yes, neighbor meaning within a classroom right next to you on the same router. Because the moment you're on a different router and or cellular data, you're gonna have a different
Yeah.
IF config.
Yeah, yeah. So this is an interesting command because I have never tried that on Windows, which I am now going to try
I'm also going to try it.
because I have not seen this. I don't think I have.
.me. Okay, so it gave me my IPv6. It literally gave me nothing except my IPv6.
I got the same. So
Yeah?
that's interesting.
So
That's very
I've
interesting.
never seen that command. And why does it? It's literally it gives you no context for anything you just did. It literally only gives you the IPv6. What an interesting.
Yeah.
Comment. Okay.
Okay,
Oh.
so in this assignment, you will set up a core network with 2 NAT subnets to demonstrate the concept.
Okay.
Okay,
Great.
required equipment, software.
Working instance of vCore virtual machine or common open source emulator software. So
And which
we
one?
have
You're
that.
using both of those, right?
we're using vCore virtual machines. Yeah.
Oh,
And the
this
common open source research emulator software is not a specific one. It is a vague term for what the vCore virtual machine does. So
Hold on,
imagine
I just want to type that in.
there's a difference between like going to like Walmart and going to a general store. This is the text that the common open research emulator software is. They're going to be referring to like if you found anything better, you can use that too.
It is a thing.
It's a thing.
Yeah, because it's on GitHub. It is a tool for emulating networks on one or more machines. You can connect to these emulated networks to live networks. Core consists of a GUI for drawing topologies of lightweight virtual machines and Python modules for scripting network emulation.
Dude, common open research emulation is core.
I
Okay,
mean,
so literally, okay, so look at this. Working instance of vCore, which is a virtual core, or core itself. You either have core itself or virtual core. These are the two options that we're giving you. Yeah?
Okay. Well, I don't know.
Because look,
There it is.
C-O-R-E. Core emulator. So, yeah, core
Okay,
software.
so what they should have done then is put in parentheses beside the acronym CORE, Common Open Research Emulator.
Yeah. So then, okay, then we get, or what? are
Okay,
you-
so start Core Emulator.
we have it
annotate.
open, I think. Let me,
Oh, they kicked you out?
yeah. So core is open.
Okay, annotate the canvas grid with your name and student ID as text. Okay, we don't have to do that till the
We are
end.
going to skip that. Yeah.
Create a network of routers to emulate the internet.
Okay. So this is the general idea, but then we have a couple of steps to do that. Okay.
Yeah. So
Set-
set
okay.
default for generated IPv4 addresses. Tools, IP addresses, create new entry to the list and select Cloudflare.
So we go here. IP addresses. What was it? Was it just ones?
Yeah, but it's invalid. You have to say make a new one.
yeah, no, because it's saying invalid because there's nothing in this field, which is the stupidest thing I've ever seen in my life. I can only
There you go. That
save
then
that.
save. Yeah.
Okay, then I also, hey, what I could do is I could literally send you this thing so that you can read this on your computer too. But okay. Anyway, because well, actually, I could do this. Yeah,
All right.
there we go. Oh, what?
You could go ahead and also go back to that page.
Which is that page?
Oh, okay. No, never mind. Just scroll up a little bit.
Oh yeah.
Okay.
Is there anything? If I do this, yeah, here we go, honey.
Make sure that IPv6 is disabled.
Nice. Okay, tools, IPv address, enable IPv6 is not selected,
Okay.
so we have to assume that that is off.
Okay.
Okay.
So scroll down.
Oh, disable IPv6, remove the enabled mark. Click OK.
Okay, yeah, that's what you did. Okay.
Generate
So
a ring of net. Oh, yeah, you can read it.
Yeah, generate a ring network of 5 routers. Choose the router icon from the left and click the canvas 5 times. So you know what a ring is. You just make a circle of these.
Okay, and then
Now create links between the devices. Right click a device and choose link canvas 1, select node next node name. So which one is the first
so
one?
if I won and I right click
Yeah.
link canvas and 2.
2, link canvas 3, 3, link canvas 4.
Why are we doing it this way?
I don't know. Link canvas 1.
Okay.
Well, this is a topology. This is a very old concept in networking, and so they're trying to teach you this.
Okay, so here is, yes.
Organize the routers for nice visual appearance. Then using annotation tools, create an oval over all routers and name it Internet.
There's no good way of doing this.
Well, yeah, they want you to have it as kind of circular.
Yeah, there's no way to. I guess this is as good as I'm gonna get.
Yeah, if you offset them a little bit, I don't know.
Yeah, look, that's as good as you get to have all the IPs in there.
Why
And
don't you spread them out a little bit further away from one another?
First, I'm gonna move them to the screen, assuming we're gonna do that. There we go. And then we do an oval.
Yeah.
And they wanted this to be called the internet.
Yeah, Internet.
You're getting quiet, yo.
Yeah, internet.
Yeah. Okay. Uh, yes, correct. We have now done what they have asked. Hey, that's
Yeah,
about right.
it's really close.
What do you mean very close? It's
Uh,
identical.
yeah, no, it's not identical.
Yeah,
Come on.
5 to 1, 1 1 5 1, 1 1 5 1. Next one 1 1 5 2,
But
1 1
oh,
5
okay.
2.
You
Next
meant
one.
that way. I meant that they have
Oh,
also offset it so that you can more clearly see
yeah.
the numbers not marked through with a red line.
There we go. Gotta wiggle these a little bit because otherwise it's bad. Okay, ready? Test that the router works as expected. Start emulation session. Boom. We have started it. Okay, it took a while, but it started it. And now there's speed at which it's going at about 4 kilobits all over all the circles. Okay.
Yeah.
We have throughput. Enable IPv4 routes from widgets. Observe. Widgets, observe widgets. IPv4 routes.
We call them widgets where I come from.
Widgets. Did I click the correct one?
Don't be an idiot. Pronounce it widget.
I'm gonna say it went correctly. This is the one. Enable IPv4 routes from widgets.
Yeah.
Yeah.
It must be that one. Yeah, because that's the only one that has all of the words in it.
Verify that the IPv4 routing tables are as expected. Hover mouse over the routers.
Wow, that's pretty cool. What's this zebra
why are
stuff?
we the zebra? I guess it's a Z and that's a P. So
device Ethernet 0 Proto Zebra. Scope link Proto Zebra. Proto Zebra.
But they clearly have a list of all 5 things with their IPs respectively.
Hey, point out another one to see if it's like rhinoceros or something. Zebra? No, they're all zebras. Okay.
And they have the same things. Each one has the exact same things, but in different order.
Okay.
I think.
Yeah,
it's in different order, but it's the same list.
Okay.
So, when it says via something, dev, etho something, photo, zebra, metric something.
Yeah.
For this one, 1120 is via 1112, right? 1120. Where's 1120?
I don't think we had a 1120. It was just 1121.
I think this is 1120. Or it should begin in 11.
It didn't do that.
It's weird because the connection between the N2 and N3 is 1120.
Yeah, scroll up a little bit on your picture here. No, you see they have 1151, 1152, 1111, 1112, 1121, 1122. Wow, these are very different from what we have.
But
1131.
Wait a second. No, they are not. Look, if you look at N1, N1 goes to N2 with just a list of ones, and then ones, and then 2. N2 goes to N3 with 1120 networks. It's because this is the first one. So N2 is the first 1120 host, and so it is given 1121. And the second 1120 network holder.
I see what I was doing. Because I didn't realize that their N1 was at the top and your N1 was to the left.
We're gonna do it. We're gonna do this. Okay, we're gonna do this because it's easier to have them. Okay. There's no reason for us to make this difficult for ourselves. Okay. Like that. There you go. And then we zoom in. Yeah.
All right.
Identical. Okay. Yeah?
Yeah.
Also,
Now I see. I was totally not aligning it properly in my mind.
There we go. Okay, so here we go. Okay, we I guess continue.
Yeah.
We enable throughput through widgets. I'm hoping.
So let me just
We
read
did?
what it says. So verify that the IPv4 routing tables are as expected by hovering the mouse over the routers. After running a while, all routes should get the routing information from the neighbors, and all routers should have the route to any other router, which
Okay,
they
that
all
is
have.
correct. We have, okay, if we go in here and look, that's 5 routers in a connection. So
Yeah.
you should see 5 in each one. That's what we're looking for, not all the proto, zebra,
Yeah.
rhinoceros information. So each one has 5 links.
So then the next one is to enable throughput from widgets.
We did that. Widgets, throughput enabled.
Okay. Then the
I
next
guess we go.
page.
We continue. We continue. So the last one here is start traffic flow from any node to another. Double click any node to open a link. Yeah, and then ping node with this many byte packets. Ping address.
Now they're testing your ability to read that text, which is there, that ping IP address, that you know that to put, not type out IP address, but to type out an IP address.
I'm gonna go for, let's say, this one. So this is, I'm going for this connection. I'm gonna
Right.
go on it should, if my brain works how it's, if I'm networking with my brain, okay, this is what should happen. The direction of connection goes on the right side. And so when I'm gonna send these bits, N5
Okay.
or any connections to N5 should not light up.
This is where it gets really funny, okay? Because there's a lot of complicated protocols that they have come out with, and one of them is open the shortest path first. And so what it will try to do is not go through 2 routers. It will try to go through only 1 routers to the destination.
Okay. Well, let's see what happens.
But since this is a ring network, it may not be able to go other than the way your logic was dictating.
We'll see. We'll see. Is it a circle?
Yeah.
It's a circle.
It's a complete circle, but why? Okay. I have to ask, why is it going both ways?
I know. You know what? I'm gonna give you my theory. To send information to this location, you have to go in this direction. Okay?
Okay,
But-
try only
Oh,
sending.
you didn't even wait for my whole theory. What's the hell? What the
Well, just to test it out, try to send it to the closest node.
Okay, so that would be. Do I go 1151?
I think
So
it's
that-
1112 is the closest, or the opposite way. 1 1.
Oh yeah. Okay, so let's
5,
just
1.
go with 1 2. So that's going directly in that direction. Okay.
Okay, that makes sense to me. Now try pinging the next one, 1122.
2 2.
Okay, that makes sense. Now try 1132.
Yeah, that makes sense. No, that makes sense to me. That makes, you know what? That actually makes sense to me.
Okay, well, one more. Try the last one. 11.
It's gonna make a
4,
straight
2.
line. It's gonna. Oh, 4 2. Okay, that might still
okay,
go.
but no. If we did do what you're thinking, 1151, then it should be a straight line.
Well, let's try both. Okay, so that's obviously a straight line, but let's try 4 2. No? Okay. You know what? My theory This is my theory, and listen to that. When you connect from N1 to N2, it's a direct line. Pinging is the act of sending a packet and asking for it back. So
Yeah.
you can obviously send that through the same most connected easy line. Okay. Now, when you go to N2 to N3, that's if you go to N1 to N3, that link is still only 2 connections. So it wouldn't do a full circle because it doesn't make any sense. Right?
Yeah.
A full circle doesn't make sense when you still have less connections to ping from the original location to what you're pinging. But when you go like 1, 2, and then 3, N4 is 3 connections or links away from pinging it back. And since it's a circle, at this point, it's actually going to choose the lowest connections to go back to the original location.
Yeah.
And I bet if we made a circle.
Ping also 1141.
Okay, wait.
Oh, sorry. Just
141.
okay.
Yeah. Okay.
But if you then went to a ping 1131, it would probably make the circle.
Probably.
No, it
Huh.
didn't. Okay.
Okay.
I don't exactly understand.
Okay, my theory is breaking down because I don't know what kind of edge case we have found.
Because, if you're trying to ping one side of the router, which is 1122, and not 1131, that one router we were just pinging,
Yeah.
we're going through the router to another network. What was it? Network IP.
Yeah. Because like for some reason here it can go right side router, left side router, right side router, left side and right side, and then end here. But for some reason when we ping the N4, it wants to go the full circle for no reason.
Okay. We could try systematically going with the IP address on the entering side and then on the opposite side each time.
Okay.
So
even though this is tedious, I want to see what that looks like. Also, we're gonna reset this.
So the first one, would be 1112.
1112. Here we go. N2 on our side. Correct?
Okay. Now the next one would be 1122.
Not 11.
Yeah, we're doing it slightly different. Only the entering
Okay.
first.
Okay, so we're coming clockwise. I think that's what we would call it.
Okay, you expected. The next one would be 1132.
Okay.
Okay, see that I don't expect, but okay. Then let's try 1142.
1142. Okay.
Well, generally, it's going based on the idea of open the shortest path first. So generally, it's like kind of making sense. But now let's try going to the other side of the router from the very beginning. Going,
so 111.
1121.
Yeah. 1121.
Yeah, that would going the same clockwise fashion.
You wouldn't want to do the... Okay, so you're kind of walking backwards, but okay. Okay, there. So we're going to the wrong side of the modem of N2, correct? Yes.
Yeah. Okay.
All right.
So that's expected, and then the next one is 1131.
31. Okay.
Expected.
I'm somehow expecting this next one to be goofy.
Well, yeah, the 1141 should, of course, do what it has been doing, and Okay.
Okay.
Didn't do it this time.
Okay. I actually have no clue what's going on at this point.
I think it is actually following the rules, and that's why what is happening is happening.
But why? Is it because of the how we connected them? I think it might be that. The linking them together with, rather than just connecting the lines, you know, but right clicking them and then doing like connected to
Oh,
them.
hey, but there, I saw the acronym OSPF, Open Shortest Path First. Version 2, Open Shortest Path First. Version 3.
Zebra?
Yeah, I don't know what Zebra is. That's a whole other thing. I have to find out what that's about. But yeah, it's generally following the rules. So I kind of understand why it's... In one case, it is making a circle, but on all the other cases, it is doing what I would expect.
Yeah. Okay, well, they say this in a way that would make it so that maybe you have to know a little bit now to do it. But then down here, they give you the command.
Yeah, so if you followed that command, let's see if we get the image that they get.
Well, we did
the way
this.
that yeah, that's what I thought.
You mean like, so they opened up this, and they did, what, 4? Yeah, that's about right.
Yeah.
Yeah. Identical pictures.
Yeah. Okay.
You know, and this is just the next step, and we're seeing that happen.
Yeah, well, we did much more testing of this thing than they did.
Well, yeah, but that's learning is, you know, those who want to learn will do the work, and those who just want the answer will, you know, not do as much work, you know. So, okay, we have a circle. We're a little bit over time, but we'll continue maybe to 30 past.
Yeah. So now, create a home network consisting of a home router that does not participate in dynamic routing, but uses a single static default route to internet, and provides NAT functionality, network address translation functionality.
So now that's like what we're gonna do with these next steps.
Yeah.
Know? And it should look something like this: a router with a switch and a computer. Okay.
Okay.
But okay, stop the emulation, of course. Add a router and a switch and a PC. Okay, so that's exactly what we saw: a switch, a router, and a PC. There we go. I should not have started it. Okay, so we have these. Connect the devices using links in the following order. See next screenshot below as well. Add a link from home router to an internet node. So we're gonna right click this and we're gonna do link canvas. Oh, okay. I guess we have to go big screen. Canvas and 2. There we go. I'm gonna do it this way so we can see the IP.
Yeah, but definitely make enough space so that when it adds the link speed, you can see it. Because now we know that it puts the link speed right in between the two numbers.
Yeah. Okay, so then, man, I don't understand why this has such a hard time. What can we? That is what we did. Yeah. Change the default.
For generated IPv4 addresses, going through the tools menu, IP address, select the 192.168.0.0.
Yes, because this made a link now with the 1.1, you know.
Ah, okay. So you would have to like delete that link.
No, I think they wanted that to happen. Following order, so add the link, and they're assuming you did the earlier stage with the thing on. And so I'm gonna assume this is correct.
Let me see the other side of the router.
It's actually even the same thing as here.
Yeah, let me see the other side of the router. Okay, so you haven't added the other link yet, so it doesn't show it. Okay.
Yeah, so this is gonna ask us to do tools, IP addresses, click on this one.
Yeah.
The 192.168. Do save. Tehtävänantoon. Okay, I guess I'll just do this then, because it's trying to mess with me. Okay. Okay, I guess I have to make this into there. Okay. I don't know if you can read this though.
Yeah, I can.
Okay. So change the default. We did this. Click OK. Add a link from the home router to the switch. We click the link. Home router to the switch. Add a link from the switch to the PC. Correct. Why does the order matter? It is just to make the setup easier. Core names the router interface as Etho0, Etho1, Etho2,
Yeah,
so long.
It stands for Ethernet 0, Ethernet 1, Ethernet 2.
Yeah. As you add the links, as you add links, by default, when you enable default route service, it is Etho0. That is the outbound interface, similar to when you enable NAT services. Etho0 is a public IP interface. As an alternative, you can generate... Oh, that's what went wrong! That explains so well what happened. Okay.
As an alternative, which is probably what you started out with, is you could create links in an arbitrary order and then edit each configuration file correspondingly. So, which makes it a lot of work.
This is for NAT. Okay, I'm gonna save this. I'm gonna open this one and show you what happened. When I did this last time, I could not figure out why, when I was sending packets from one of these computers over the internet, it would be able to send it all the way there and never back. For some reason, it wasn't able to send any info back. It was only able to send it in one way, which was really weird. I couldn't understand it. What I'm gonna bet what happened was, since Etho1 is considered a public thing, because I connected them all haphazardly and in different orders, I probably connected the router to the switch, and the switch was considered now the public connection. And that's why information could go into the networks, but never out of the networks.
Okay.
You see, if a computer on the quote-unquote on the internet, like we saw in the documentation, anything in the public domain cannot send something into a private domain without a mapping to the info. But since I had the internet connected to as Etho1 or Etho whatever the hell, it was considering the internet the private side and my LAN as the public side. And so sending info back wasn't possible.
So yeah, I would suggest making a kind of a cheat sheet or whatever you call it, a general help file.
Yeah.
That it gives you this order of operations and the reasoning for this order of operations, so that you will remember in the future when things have gotten about 1,000 times more complicated, why you do it in these orders, this order, and not just whatever you want, and just willy-nilly do whatever.
Yeah. Yeah, but I will write this this thing either next stream or then when I have time, because I have to go to Helsinki soon, so I have to.
Okay.
We'll get done with. Yeah, we'll do 4 to the end, and then we'll go. I will have to go.
Okay, so organize the home network for nice visual appearance. Then using the annotation tools, create an oval over all routers and name it home number 1.
Organize. Okay, so yeah, they want us to oval it up. There we go. Did they want us to make this also like... Wait, how do you make a yellow? I forgot. Like, there we go.
Yeah, that's a mustard.
I think that's a yellow.
Yeah, that's we're really close to yellow. Yeah.
Yeah.
Not pure yellow.
Well, isn't it pure yellow? Because I simply maxed out green and red, so that's a pure yellow. Yeah, that's
probably pure yellow then.
Okay. Yes, we did this. configure home router, that one. Right click, choose config service. Wow, okay, I've never seen this one. Enable default route, IP, forward, and NAT. This is at least IP forward. Okay, default route, IP forward.
Okay, so what did you start with here?
Okay,
configure home router, right click, choose config services, enable default route. So you had to click config services.
Yeah, so right click in this config services.
Oh, and then this popped up. Okay, I didn't see that.
And so we enable NAT.
So then you went enable. So you enable default. Show me the default.
So I'm gonna go in order. Enable default route, which is this one. Then there's IP forward, which is this one.
How did you know that was in utility?
I went through them and read the services.
Oh, okay. Yeah, you're able to see it much quicker than me. I would be very slow doing this.
Remember, whenever like let's say you're reading a book and you're changing pages. Like let's say it's a comic book, right? If you change the pages at your speed, I'm gonna be really lost really fast. But if you change your wait. Man. Okay. So what I was saying is basically, since I know where I'm looking and what I'm gonna input to the computer, when something shows up, I'm not gonna be surprised by the new info. So I will be able to take that info that I'm not surprised by and insert it into my brain faster than you.
Okay.
Because you're not waiting for me to click the next button. Because you're not me.
I just also would have expected in the instructions over here that they would have told you, you go to group utility, you go to service IP forward. You know, that's why it threw me off.
Yeah. But here we basically click these.
Yeah.
Was that all?
That.
Disable.
Open shortest path version 2 and version 3 and Zebra.
I guess we don't do it here. We save this.
Okay.
I think.
Yeah, it's lacking some information here. Oh, there it was.
Yeah, but is this what is deprecated?
That deprecated means it's no longer being used, so don't pay any attention to this.
Oh, so this should be correct then. OSPFv2. This OSPFv3. This.
Well, that would be enabling them, wouldn't it?
Zebra. Well, if you have services deprecated, wouldn't this make them deprecated?
No. This is something that there used to be available, but they're trying to get rid of it.
Okay. Well, how would you then
try the edit?
Oh, okay. Edit.
Oh no, it's not that. Oh, okay. You were choosing services deprecated.
Yeah.
Okay, don't choose that one. Just try config services. Okay, not this one. It was the one below it.
Yeah. So configure services, but this one, like we configure. I'm gonna.
It also has deprecated in it.
Does it?
Yeah. If you go to Quagga, whatever, I don't know what that means, but here they are. Go to security and utility. Okay, well, based on this, Quagga is the only thing available to you, and because this is where OSPF version 2 and 3 is, and Zebra, but you shouldn't click those. They're already deselected.
But that's the thing is, okay, let's save this. Let us start this. Because when we were right-clicking these things, you had services, and then you had a bunch of services.
Yeah, so here, when you do that, you could...
They are disabled. They don't have
go back to whatever you were looking at. You go too quickly.
This is the internet. Node 2. It has OSPF v3 and 2 and Zebra.
So you don't have these available to you on the router.
No, they are
Okay, well, then
disabled then.
they're disabled. Yeah.
Okay, save. we're saved. It's saved. Don't worry.
Yes.
Okay, so it should look like this. Let's look at
Yeah.
the IPs. 1161, 1161, 1162. That is. Oh well, this one is 11620, so I'm gonna change that. I don't know if that's important, but I just don't want it to be messed with that heavily. Okay. Then the switch.
I didn't see the 620.
This router, the connection to N1 was this one, so that's Etho, and it was 11620 rather than 1162. Small, very small difference, but I don't think it actually matters in this case. Then the connection to the switch in the image. Oh.
Okay, so it also did that 0.20.
Yeah, for some reason it's wanting to put 20 in everywhere, so I'm gonna. Well, actually, yeah, it actually says that this is 1. Oh.
Yeah.
Okay, so that's same, and then this one they wanted to make. I'm just gonna make it like this so that we don't have to guess. You know, not to guess what's wrong then later on. Okay, so that follows the picture, you know.
Yeah.
Okay, so we go down. So here's to test. Start emulation session. We start it up.
Verify that IPv4 routing tables are as expected. Hover mouse over the routers. Internet routers have routes to any internet router and home router. Home router has only routes to nearest internet router, default route, and home private network. Okay, so if you hover over these other routers, there should be like a 6th one.
No, yeah, there's 6.
Yeah, so, and then if you hover over the home router, it should have its nearest router that it connects to, so
and
it's
2.
the...
Yeah, that is 1160. It's it's the second
Yeah,
one.
yeah. And then it should know about this computer here, so it knows it.
Yeah.
Yeah.
Okay. So we know that it's correct. Generate traffic from one PC to any internet node. Okay, so we double click the node 8.
And then ping, let's say, 1142.
Let's like put some traffic in there. And 1142. Oh, is that the trolling one?
No, well, yeah, it's the farthest one away. I want to see what kind of circle it makes. Yeah, yeah.
It did it again. Okay, so it's consistent. So if you have 5 nodes and you connect from a node over 3 nodes, from the longer side, it will always make a circle.
So change the ping to 1121.
Okay, so Control C that. 1 1. What are you saying?
2 1.
2 1.
Yeah, there you go. That's an
interesting
thing.
So you're not saying that it would go in a full circle to get back to the beginning of the N2 node?
Well, this makes sense. It should only go there, and it should not go further. But if you went to do ping 1111, it should also not do a circle.
Yeah, it's not doing a circle.
And do 1151. We'll see if it does the circle.
It shouldn't do the circle. It should just connect to this one.
Should, yeah. Okay.
Okay,
but if you do the move your terminal a little bit. Do 1142, then it will probably do the circle. Yeah, there you go.
That's... Oh, but I have to ask then. It should also make the circle with this.
Which one?
No, okay, so why does it know sometimes?
Well, it has to do with this 1142 being in between these 2 routers. It's
But look,
like
what is the difference between going N2, N3, N4 and N3, go N2, N1, N5?
count the number of routers.
There's there's three on both sides.
Yeah,
Yeah?
that's why it makes a circle.
Yeah, but yeah. But look, if I ping 1142 from N2, it makes a circle.
Yeah,
If I do the same with N1 and 1132, it does a circle.
yeah.
Why does it make a why does it not make a circle when I talk from N1 to N3?
If you it depends on which address you use.
Well, I'm talking about the always the longest direction.
Just remember that these two numbers next to each router are relevant to that router.
Yeah.
And they're just coming from different directions, and it's how you address that router from that direction. So the if you type in I don't know how to give you an example, but it will always create a circle if you ping from one of the routers to this 1132 based on the router that you just chose. It should do a circle.
Okay,
And
so
if
it is
you
consistent. It is consistent then.
and if you pinged from 5 to 1122, it should do a circle.
1122. Yeah. So it is doing a circle then. Like every time in the same scenario.
It's based on the number in between those two, but for some reason, and I'm not exactly sure why, I would have to read some serious docs on this.
Yeah.
Why if you chose the other one, it wouldn't do the same thing. So if you pinged from exactly the same one to let's see, where were you pinging from? I forgot.
I actually don't know anymore at this point.
Go ahead and stop that.
This is 5. Yeah, I'm talking from 5 right now.
So if you pinged from 5 to 1121,
yeah,
it would not make the circle.
No, it would go through N1 and come back.
So, but if you did it again from N5 to 1122, it will do the circle.
Oh, I know what's happening. I get it. Okay, let me get paint out because, it's much simpler. Okay, it's much simpler than we thought. Circle, circle, circle. Okay, these things are connected. We don't need the other number. So this is just, this 5 is 5, 1. This is 5, 2. 1, 1. 1, 2. 2, 1. 2, 2. 3, 1. 3, 2. And then okay, so what's happening is I'm gonna use this. Okay, so when you ping from this, I'm gonna ping from this location to this side of this location, right?
Yeah.
What happens is it's 1, 2, 3 connections to then get to this location, right?
Yeah.
Now the thing is, when I go to this location, it's 1, 2, and you're here. So that was 2. Now, when I go and I can try to connect to this. Like, why there's a difference between these two at which side it comes from is within the oh, okay, yeah, like this. Within each of the routers, there's actually a hidden extra cable. Okay? And so the logic, and let's not number them, but they have their own wire inside of them. And so what happens is, when you're just trying to jump past a router, it doesn't use the router cable, right? So this is 1, 2, 3. But let's say you are trying to go to this side of this. It goes 1, 2, and then it uses 3. So it then connects to this side.
Yeah.
You know? So that means that connecting to this from this side is 1, 2, and 3. And connecting from this side is 1, 2, and 3 inner cable. Right?
Yeah.
So that means that whatever, if the amount of cables is the same from both, sides, it'll just and you pick this one, then it'll just pick the one you chose as a safer option than doing something else.
Yeah.
Does that make sense?
Huh?
Does that make Yeah, but
Yeah.
does that make sense?
Yeah, I know what you're talking about. It's just I don't know the exact technical reason why this is so, but it makes total sense to me.
Yeah.
What
But
you said.
Yeah, because it would make it so that it would always choose either the fastest or the most precise way of connecting.
Yeah.
And that's pretty good. That's a pretty good standard to go with,
Yeah, it does make sense.
Okay, but let's speed run this because I really gotta go. Okay, if you have a problem with pinging outside the LAN, which we did not have, right-click your home router, choose config, go to NAT, configure, ensure that 3 rows of concern. Let's do this actually.
And ensure that 3 rows concerning your inside interface are commented with the hashtag.
Okay, so let's pause. Not double click, right click. Home router, config services, AT.
Okay, so you went config services, NAT.
And I guess I configure.
Select the service to configure.
Oh, I have to click here.
Oh yeah,
okay,
there, yeah.
Yeah, trying to figure out what the hell I'm doing.
Here you go.
Okay, so configure and ensure
Yeah,
that
'cause
3
this-
rows concerning your inside interface are commented with a hashtag. Okay, so
those first 3 lines, the
the
bin, the shell,
the shell,
generated by
the
security Python script, NAT out the first interface by default.
Okay.
Network address translate out the first interface by default.
And so they want all those be. Why would those not be hashtagged out? Those are. I guess there can be an error.
Well, it means that you have probably created something much more complicated, or there was something somebody already did which was much more complicated, and they did not comment out these lines, which kind of change
Yeah.
what is going to be happening in the script.
Well, I'm gonna close that so we don't mess with it. There we go.
3 rows concerning the outside interface should not be commented. Which interface is which? Double click the router and see IP addresses of ETH0 and ETH1. Ethernet 0 and Ethernet 1.
And that's this one and this one.
Yeah.
And then verify that you cannot reach private IPs from outside. Wait. Verify you cannot reach private IPs from outside.
Okay,
Open
so
terminal
what
and
you
instrument node.
What you should do is choose one of those and then try to ping 192. I can't quite read the.
Oh yeah, but
there.
we're gonna guess that it's 192168. Okay, I can't read it myself. Oh, it's 20. Okay, so 0 and 20. Ping
Unreachable.
unreachable.
That's what you should get.
Double click and test the ping of this in the other direction.
Yeah, now you should choose the computer and try to ping any router anywhere, and then it should work. So
Well, we
like
already
1,
tried this, but
so 1132, you know,
we're just
or
gonna
yeah,
go with the
or
simplest
that,
one.
yeah.
And it makes the line. Yep,
Yep.
makes the line. That's cool. Okay, so this confirms that when I did the routing task, which we already did, I had misaligned the etho order so that it considered internet the private one and the public one the LAN. That's what happened.
Yeah.
Okay.
And that's very important to remember in the future, because you will be making more and more complicated versions of this.
I'm gonna save this. We're gonna have to do this later because I gotta go right now. Okay.
I really understand, yeah.
But it's interesting, and we should definitely go through these because this is a very interesting course, I have to say.
Yeah, because it starts to remind me of things that I have not looked at in a very long time.
You could become a network engineer through my schooling.
Yeah, well, I used to be one, but now, you know, it's been so long that I just haven't done it.
Yeah. I mean,
You know, when you don't work with something for a long period of time, this is what happens. You forget it all.
But you know, this is a good way to bring it back in memory. Maybe you can start doing networking again. Who knows?
Yeah.
Okay, but I gotta go. I love you.
All right.
I'm gonna have
see
to
ya.
end
Love you
soon,
too.
and I gotta here. You know.
All right. Bye-bye.
I love you.
Love you.
Goodbye.
Bye.
I'm gonna end stream pretty quickly here because I'm in a hurry.